Welcome to part 5 of the chapter Coordinate System and Straight Line in Two Dimensions. Today, uh, our first problem is problem number 14, and it is the coordinate of foot of perpendicular from A0, from A comma 0 to y is equal to mx plus a by m is options a by m comma a, then 0 comma a by m, 0 comma minus a by m, and am comma 0. The question is, from this point a comma 0, a point on x-axis, what is the foot of perpendicular to that straight line? Options is this. So there is no need of drawing. Still I am drawing it. A comma 0 is a point on that, and y is equal to mx plus a by m is this. So actually this is the straight line, its gradient is m, and it meets y-axis at the point a by m. This is a by m. Now from a comma 0, perpendicular is drawn, and we have to find the foot of perpendicular C. So suppose alpha comma m alpha plus a by m is the foot of perpendicular. I have taken a point on that line, parametric coordinate I have taken x is equal to alpha, then y will be m alpha plus a by m, known as parametric coordinate. It is very useful because in that coordinate only alpha 1 is unknown, so it is very easy to calculate. So I have taken C is equal to that. Now, as because it is perpendicular, so its gradient and its gradient of the straight line product must be minus 1. So gradient of this point is, say, A, gradient of AC. Coordinates of C is mind that this one, not this, they are options. Coordinate of C is this. So y2 minus y1, that is m alpha plus a by m, y2 minus y1 is 0 divided by x2 minus x1 is a, gradient of AC. And very clear that m is the gradient of the straight line. This straight line, that means this, its gradient is m. Therefore, m into m alpha plus a by alpha divided by a by not alpha, it is m by alpha minus a. Product of the gradients is minus 1 because they are perpendicular. Now simplify, m square alpha plus a is equal to this into that, that is a minus alpha, a cancels. So taking alpha common, m square plus 1 is equal to 0. But you see, m square plus 1, it is sum of two square quantities, cannot be 0. So only possibility is that alpha is equal to 0. So alpha is equal to 0, and we have to find the coordinate of foot of perpendicular, that is a coordinate of C. In this is C, put alpha is equal to 0. So C is equal to 0, comma, A by M. This is required foot of perpendicular. So 0, comma, A by M, option B is correct. Next. Next, problem number 15. This problem is the foot of perpendicular from origin to a straight line is 3, comma, minus 4. Then equation of the line is options 4x minus 3y is equal to 24, 4x plus 6y plus 5 is equal to 0, 2x minus y is equal to 10, and 3x minus 4y minus 25 is equal to 0. Now, in that problem, given that from origin, foot of perpendicular on a line is not given, foot of perpendicular from origin to a line is this. Then equation of the line is what? It means this is origin O, and 3 minus 4 is a point somewhere there. This is a straight line, 3 passing through 3 minus 4 perpendicular. So we have to find equation of that line. Clearly, the straight line passes through 3, comma, minus 4. Now, somehow, if I can manage the value of its gradient, then equation will be of the type y minus y1 is equal to m into x minus x1. Let us suppose that this is our m. Gradient is m. Now, here also we calculate gradient of this and gradient of that given. So, given that we have taken it. Their product must be minus 1 because they are perpendicular. Now, gradient of OA is equal to minus 4 minus 0 by 3 minus 0. So, minus 4 by 3. So, clearly, gradient M will be such that their product is minus 1. So, it is 3 by 4 because you see their product is minus 1. So, gradient M, gradient of the required straight line is 3 by 4. Now, the equation in the problem become very simple. Equation of the straight line will be of the type y minus y1 is equal to m into x minus x1. y1 is this x1, y1. So y plus 4 is into 4. 4 into y plus 4 is equal to 3 into x minus 3, giving 3x minus 4y minus 9 and another 16. So minus 25 is equal to 0. So required equation of straight line this is 3x minus 4y minus 25. So this is our answer. Option B is correct. Next, next is problem number 16. This problem is the angle between the lines joining origin and the point of intersection of 2x plus y is equal to 1 and 3x square plus 4xy minus 4x plus 1 is equal to 0 is options pi by 2, pi by 2, pi by 3, pi by 4 and pi by 6. Here it is the problem is that from origin, first of all, this is a straight line and this is a second degree equation. This is not straight line, any curved line. It is of that type. Suppose this equation represents by that curve, and one straight line is given like that. This straight line. They meet at 2 points, this and that, at A and at B. O is the origin. Now the given problem is from origin, two straight lines are joining, two straight lines are drawn. Which one? To the point of intersection of this and that. Point of intersection of this and that is A and B. That is this straight line and that straight line. What is angle between them? This is the problem. So clearly we have to find the value of coordinate of A and B. How? Simply by solving this and that. Solution is very simple because y is equal to 1 minus 2x. Put it there, only y present here, only in that case only. That is, we get solving 3x square plus 4x into y. Y means 1 minus 2x minus 4x plus 1 is equal to 0. That is 3x square plus 4x minus 8x square minus 4x plus 1 is equal to 0. Now cancel. That is minus 5x square, they together, plus 1 is equal to 0. That means 5x square is equal to 1. Taking minus 5x square into that side, that is x square is equal to 1 by 5. So x is equal to plus minus 1 by root 5. If x is equal to 1 by root 5, y will be equal to, y can be obtained from there, 1 minus 2x. 1 minus 2x means 2 by root 5. So point A is this, comma that. When x is equal to minus 1 by root 5, y will be same 1 plus 2 by root 5. So the two coordinates are A is equal to 1 by root 5, comma 1 minus 2 by root 5, and B is equal to minus 1 by root 5, comma 1 plus 2 by root 5. So we get A and B. We have to find the angle between this and that. From here, we can calculate gradient of OA, and gradient of OB also we can obtain. If their product is minus 1, then angle will be 90 degree. Gradient of product is minus 1, so angle is 90 degree. If it is not the case, then knowing m1, its gradient, and its gradient m2, theta, if theta be the angle, then from the formula, tan theta is equal to m1 minus m2 by 1 plus m1 m2. Using this formula, we can obtain the angle between two straight lines joining O to A and O to B. So now, m1 gradient of OA is equal to, this is 0, 0. So it is actually in fact 1 minus 2 by root 5 minus 0 by 1 by root 5 minus 0. That is root 5 minus 2. Now gradient of m2, that is gradient m2, that is gradient of OB, it is equal to 1 plus 2 by root 5, this minus 0 by this minus 0, that is minus 1 by root 5. It is equal to minus of root 5, this minus is there, root 5 plus 2. So m1 is this, m2 is that. Let us try for the product m1 into m2, how much? Minus because of that minus is there. It is equal to a plus b into a minus b. 5 minus 4 is equal to minus 1. So luckily we get m1 into m2 is equal to minus 1. Then they are perpendicular. The required angle is pi by 2. So option this is correct. And just now I told you, if its product is not minus 1, then knowing m1 and m2, that is knowing this and that, by using this formula, tan theta is equal to m1 minus m2 by 1 plus m1 m2, we can obtain the value of the angle. Okay, next. Next problem is problem number 17. And the problem is, the point which is equidistant from A 1, 3, B -3, 5, and C 5, -1 is 8, 10. Second option -8, -10. Third option 8, -10, and fourth option is -8, 10. The problem is very straightforward problem. We have to find a point which is equidistant from this, and that. Suppose the point is P, coordinate is xy, such that PA is equal to PB is equal to PC, P2A, P2B, P2C. That means PA square is equal to PB square is equal to PC square. Now taking PA square is equal to PB square, it gives us this distance and that distance square are same. That is x minus 1 whole square plus y minus 3 whole square is equal to x plus 3 whole square plus y minus 5 whole square. Now simplifying, we get this x square, that x square must cancel. Y square, this y square must cancel. So minus 2x plus 1 minus 6y plus 9 is equal to 6x plus 9 minus 10y plus 25. Now simplifying it, 8x, this is taken to that side, 8x minus 4y, a 9 cancels, 8x minus 4y plus 24 is equal to 0. That means 4 can be cancelled. We get 2x minus y plus 6 is equal to 0. We get one equation. How I get it? By considering PA square is equal to PB square. Now, once again, and because x and y are two unknown quantities, and we get one equation. So similarly, if we get another equation of similar type, then by solving them, we can find x and y. For that purpose, take PB square is equal to PC square. P is xy, B is that. So x plus 3 whole square plus y minus 5 whole square is equal to PC square, means x minus 5 whole square plus y plus 1 whole square. As before, x square must cancel from both sides, y square cancel from both sides. 6x plus 9 minus 10y plus 25 is equal to minus 10x plus 25 plus 2y plus 1. Now 25 cancels, so that 16x and minus 12y, this and that, plus here is 9, there is 1, plus 8 is equal to 0. Again cancelling by 4, we get 4x minus 3y plus 2 is equal to 0. Now, very easily, by solving these two, we can find the value of x and y. This part, you please solve it. Solving this and that, and our answer is, I tell you, answer is minus 8 minus 10. This is correct option. Minus 16 plus. You see, this satisfies that. This also satisfies this. So you have to solve it. Next, it is problem number 18. The angle between the straight lines x minus root 3y is equal to 5 and x plus 3y is equal to 4 is the angle between root 3x plus y is equal to, in fact, it is 7. The angle is how much? Oh, sorry, I have copied wrongly this one. It is, in fact, root 3x plus y is equal to 7. Angle between this straight line and that straight line is how much? So options 30 degree, 60 degree, 45 degree and 90 degree. So this type problem, to solve for this type of problem, find gradient of that straight line m1 say and gradient of that straight line m2 say, obtain that very easily from the equation. Now, if their product is minus 1 m1 into m2, then it will be angle between them will be 90 degrees. If it is not, product is not minus 1, then by using the formula tan theta is equal to magnitude of m1 minus m2 by 1 plus m1 m2. m1 m2 known from this and that, you can very easily obtain the value of angle. Now from here, its gradient m1 is equal to, in fact, it is 1 by root 3. Because it is of the type a root 3y is equal to x minus 5. So y is equal to 1 by root 3 into x minus 5 by root 3. So it is of the type y is equal to mx plus c. So m is 1 by root 3. So its gradient is 1 by root 3. From here, by taking y into another side and divide by its coefficient, then only you get it very easily. Similarly, here is m2, it is equal to minus y, that will be equal to minus y is equal to root 3x. So its gradient is minus root 3. Now we are lucky enough that m1 into m2 is equal to 1 by root 3 into minus root 3 is equal to minus 1. So that product of gradient is minus 1, hence they are at right angle. That is, angle between the straight lines is 90 degree. Okay. let us stop today, and I request you to please like it, share it with your friends, and subscribe my channel, and I will discuss the whole syllabus for preparation of JEE main and advanced and different state like joint entrance examination. Okay, thank you.